All right, lesson 1 here in online calc. We are going to take it back to the beginning and go back to what we mean by a derivative. So we're going to cover right now how to use power law to find a derivative, what a derivative means as far as m tan, and then we're also going to look at m norm and the equations of those lines. Remember those? I know you loved them. Okay, so let's just talk about this real quick. If we have a graph and that graph has a curve, then at any given point on that graph, there is a slope, and the slope is changing, right? It's not constant. So if we're looking at what's happening with the slope when x is 2, we can draw a tangent line at x equals 2, and tangent means it only crosses one point. We can also draw a normal line, which is perpendicular, remember? So this is our normal line, and the red one was our tangent line. So each of those can be written, they're linear lines, so they both would have an equation, which is y equals mx plus b, and they would both have a slope, right, that we can find. And that slope comes from the derivative, because remember, a derivative is a formula for slope. Formula for slope. That's what a derivative is. So knowing that a derivative is a formula for slope, we can use that derivative to find the slope of the tangent line, because we know what our x is. We can use x to find y from our original function. We can use our derivative by plugging in that x to find the slope, and then we can solve for the y-intercept. So what if we do something like this? What if we start with f of x equals 3x squared minus 2x plus 1, and we're talking about x equals 0. And our goal is to write the equation of the tangent line and the normal line, okay? That's what we're going to try and do here. There's a very large part of me that thinks you can do this right now. So I want you to pause. I want you to try and do it, and then come back when you're ready. So I'll wait. Okay, done? Okay, you know how I can't stand silence. Okay, so this is our original function. Our original function is the function we use to get coordinates. I've given you x. You know what x we're working with. You can find y right now if you want, the y value that would go with that x, just by plugging in x, and it would be 1. So good job, 10th grade, maybe 9th grade. Okay, so let's find our derivative. Remember, it's f prime of x. And to find the derivative, we're going to use power rule. So multiply your exponent by your coefficient. So it's going to be 6x minus 2. Okay, so here's our derivative. If I plug my 0 into this derivative, it's going to give me the slope at that point. So if I say f prime of 0, because I asked you what's happening at x equals 0, 6 times 0 equals negative 2. So the m tan is negative 2. The derivative is this, 6x minus 2. That's a formula for slope anywhere. But I wanted to know what was happening when x was 0. I plugged it in, and now I know that my slope, my m tan, is negative 2. That means that my m norm is going to be positive 1/2, because it's the negative reciprocal. So I flip my negative to positive, and I turn the whole thing upside down. So 1/2. Now there's two ways you can find the equation of the normal line or the tangent line. Hold please, Eli's coming here. Okay, so remember we have an x, we have a y, and now we have a slope. So there's two ways we can do this. We can kind of plug everything we know in to y equals mx plus b and solve for b and then rewrite. And if we do that, we'll have 1 equals negative 2 times 0 plus b. So now we can solve for b and we get 1 equals b. Therefore, the equation of a line is y equals negative 2x plus 1. So there's one answer. And then if we do that same thing down here with our normal line, we can do that, but I want to remind you that there's another way to do this as well, and that was with point slope form. And point slope form is when you take y2 minus y1, I don't know why I'm smushing this, and that equals m times x2 minus x1. And if you do that, then you're going to have 1 minus y equals m, which is a half, times x, which is 0, minus x. And you leave the x and the y in there because we want them in our final equation. But the beauty of this one is it doesn't have a b to mess with. So then we have negative y equals, distribute here, 0 minus 1/2 x, which of course if we turn all of that around, ooh, I lost my 1. Okay, so we end up with negative y equals negative 1 minus 1/2 x. We're going to switch all this around and move that negative, so we're going to have y equals positive 1/2 x plus 1. And there is the equation of our normal line. Okay, so.
Can I talk?
No. So I want you to try a couple of these on your own for practice. No, not you, Eli. Everybody say hi to Eli. Okay, so here are your two practice problems that we're going to call lesson 1 practice, because I think that's how we're going to kind of organize ourselves. So I want you to sketch a graph, first of all, of this. And I want you to find the equation of the normal and tangent lines with their sketch. So number 1 is going to be f of x equals 6 minus x squared when x equals 2. And number 2 is going to be for the function f of x equals the square root of x. Be careful. What do you need to do there? When I give you a full coordinate for 2. Then, just for fun, I want you to, not just for fun, that's not true. I want you to just find the derivative of this function. Wait for it, it's a good one. It looks a little tricky, and I want you to really think about the derivative rules and what you're going to have to do here. That's a bracket. So there's a lot going on in that. So you're probably going to have to multiply it out. You're going to have to make some exponents. You're going to have to get a little wild on that. Okay, so you're going to try that. And then I think I'll also list the answers below. So when you're ready for them, you can check your work. Okay, cool. Good luck. Let me know. Actually, maybe I won't list the answers. I don't know the best way to do this. I'm not going to list the answers for right now, but I'll post them later. How about that? Okay, bye.